So I think it's started. So hi guys, welcome to High and Drop. It's day 23 of AI learning, and so far I have we have covered 22 days and what we learned so far. So first thing I'm working on few projects and we have covered so far like MCP servers, LangChain basics and cloud basics. I won't say it's mastery, still I need to learn, but yeah, I got the basics. And after Langgraph, after completing the Langgraph from the Anslamba, then I will jump into some projects. So for that, I purchased few Udemy courses. So today I'm gonna start that course because somehow I feel like today I'm not grasping much information somehow. So maybe in the morning I will stream again for the next day. But yeah, so we will jump into the Udemy part first. So like I'm gonna stream it for 1 hour, next 1 hour, and I'm targeting. Okay, let's cancel and 1 hour. Let me set alarm and let's jump and grind. Okay, so what is the purpose in this thing? So we are going to do, okay, let me jump to a screen and how to minimize it. Yeah, so okay, so I have started learning this course by what is the name, Krishnayak. So I'm just learning it.
Basically, this library is getting installed within this particular folder. That is nothing but DTNP. Okay. Now, this is one way of creating a virtual environment. Now, you can probably go ahead and create your entire code, projects, whatever things you really want to do. Use object-oriented programming, write modular coding, whatever things you really want to do, and use this virtual environment. And also make sure that whichever packages you really want to install, you keep on writing it over here. And as you'll be seeing, I will be implementing in this particular way itself. But my duty is basically to show you all the ways how you can create our virtual environment.
Okay, I don't want to want to waste much time in learning the same repetitive things. So what I'll do, creating virtual environment using UV package manager. So I know basics how to use UV init to create a package and then install UVC, UV add to new package. If you wanted to add new package, just use UV add. So I feel like okay, I just jump into the important topics directly.
Hello, so welcome to the Python series. Now we are going to start our first session with respect to Python. Now what we're going to do in this video is that and the entire code that I'm actually going to specifically write, I'm going to use the VS Code ID.
No coding with
VS Code ID I find it really amazing because here you'll be able to execute your Jupyter Notebook files, your .py files. Along with that, you'll also be able to create all the environments very easily.
Library.
So it is feasible that I specifically use VS Code. Along with that, you
file operation, working with files,
extensions, code assistance,
inheritance hoops, encapsulation.
So the first step, as we are still starting, what I'm actually going to do is that over here we're going to create our new environment. As I said, in this Python series, I'm going to use the newest Python version, that is Python 3.
I will jump directly into Pydantic. Even I don't know.
So in this specific video and in the coming series of video, we are going to cover about a very important module in Python, which is called as Pydantic. Now, why is exactly Pydantic used? We'll just go through this entire documentation, and then I will probably go ahead and give you some of the examples why it will be important in terms of working with Langgraph framework and what all different kind of use cases we can actually implement very much easily with the help of Pydantic module. Obviously, Python knowledge is actually required for this, and this is just like an extension topic which everybody needs to cover. Because right now, every framework is specifically using this Pydantic module, right? So if you don't know about Pydantic, here is the entire documentation. You can just go and search for this particular.
I think I should skip it as well because otherwise I will end up.
Pydantic is the most widely used data validation library for Python. Okay, so this is nothing but it is a data validation library. Now, what exactly data validation means, I will talk about it. With your linters, ID, or PM. So if any kind of IDs that you're specifically using, this really works amazingly well and it solves various different kind of use cases. Define how data should be pure canonical and.
What are linters, IDs, and brains? I know IDs. I just wanted to know. Linters means code quality checks, and it will throw error, or maybe it will point out like, okay, here is the problem. Here you can optimize it. Brains, human cognition and logic. Brains typically refers to one of two things: human mind, core software logic.
And you need to at least have Python 3.9 plus version so that you can validate with Pydantic. Okay. So here, there's some important points why use Pydantic. Okay, so there's something like powered by type hints, with Pydantic schema validation, serialization, are controlled by type annotation. Then here you can see that speed is also one of the most important things. You can understand over here, right? We are specifically using for data validation. Now, the data validation is happening with the help of a module which is written in Rust, right? Any kind of programming language or any module that is specifically written in Rust, it is quite fast. Okay?
Yeah,
the data validation will specifically happen very much quickly. The data validation logic will happen very much quickly in the backend. Okay. So Pydantic is among the fastest data validation libraries for Python. And still, there are a lot of different important points like why use Pydantic, like JSON schema, data class is type text. Pydantic supports validation of many standard libraries using data class and type text. And around this also you'll be able to see that there are around 8,000 packages of PyPy using Pydantic. So really becomes a very popular library. And even if you consider some of the important frameworks like Fast API, Hugging Face, Django, Ninja, SQL model, and Langchain, right? Langchain and Langgraph, where we are going to focus in the upcoming series of videos. Here also you can see that in terms of
What is Django Ninja? I just, like in the past I learned Django. Core framework, whether it is a modern lightweight toolkit built explicitly to extend Django to build REST APIs. Okay, so it's like a fast API, not yeah, fast, or you can say Flask. I remember Flask. I built my college project in using the Flask recommendation system, movie recommendation system. So I built a little UI and all.
Okay. Now, to start with, I will just go ahead and talk more about it and give you the actual usage of this, right? Why exactly this is used. Obviously, many points are discussed in the documentation. Let's consider that you have some kind of API that you're developing, right? So let's say you're trying to develop an application. This application may be built in Django, it can be built in Langchain, it can be built in anything else, right? So let's say that we're trying to build this with the help of Fast API, okay? And Fast API also internally have Pydantic module integrated with this, right? Now, with respect to Fast API, when we are developing our application, internally what we do is that we create a lot of different kind of APIs. So let's say this is my API, which is like / get results. Okay, so let's say this is one of my API that we're going to specifically use to get the results of anything that we specifically search. Okay, so let's say that this is one of the API that is already available. Now, from the front end, whenever we go ahead and probably hit this particular API, then in return we get some kind of response. Okay, we get some kind of response. Now, with respect to response, the most common format of the response that we use is JSON, right? JSON basically means we will get some details in the form of name, key and value pairs. So say here on this particular request, on this particular API, we are getting a request saying that the first field is nothing but name is equal to Krish, which is my name, and then let's say here I'm going to also get age is nothing but 35, and then similarly I will be getting multiple details from this particular JSON. And once we read the JSON, and then we can probably display this in our front end user machine or in the web application, anywhere that we specifically want to display it, like let's say mobile app, desktop app, web app, wherever we really want to display it, right? Now here you can see that when we are hitting this particular API and getting the response over here, this response is having some key value pairs. Let's say over here the name is specifically string. So if I probably consider this is of a string type, here I can say that this is of an integer type. Let's say in the next field I may have a float type, then I may have some other type like boolean type, right? So boolean type of data type I am able to get this particular values, right? And all these values will be used somewhere here. You can also even do typecasting, you can convert this data type to something else, right? But since we are getting some results from this API, here we have defined some rules, right? The name should be string, age should be integer, this feature should have probably float, this variable should have the boolean, right? So there's some fixed set of data types that we should basically get from the return of this particular API request, right? Now what happens if I get, instead of string, I will start getting integer, right? Instead of this integer, I will start getting string. Instead of float, I will get a boolean value. Then it may be because of any problem, right? What happens if you're getting this specific value instead of this? Then if you have just implemented this by a normal class, right? Then this data validation does not happen, right? When you're getting the results from the API. But here our main aim is that this data validation should happen as soon as we get the response through some mechanism, right? And that is where your Pydantic will be very handy. Pydantic will be very handy, right? So Pydantic basically means that you're trying to use this module or use this library for doing this kind of data validation, which we are specifically getting from some kind of APIs, some kind of databases, or somewhere else, from some third-party APIs. It can also be from internal databases. It can be from LLMs. It can be from different kind of applications. Let's say, right? So there, what we are specifically doing that, hey, if we apply this data validation saying that we need to receive the data in this format or in this kind of data types like string, integer, float, and boolean, that is where the Pydantic can be very handy. If you do not implement Pydantic or if you don't use this Pydantic module, this data validation will not be possible. Right? This data validation, this thing, we will go ahead and do the practical implementation. Okay. Let's say, and one of the use cases that I really want to discuss about is, let's say I'm also a YouTuber, right? So I upload a lot of YT videos, okay, YouTube videos related to data science, machine learning, agentic AI, and many more things as such. I wanted to probably create an application which takes this YouTube videos, convert this into a blog automatically as soon as I upload it, right? And when I'm trying to convert this into a blog, there will be multiple steps. First of all, I need to think of a title. Second thing is that I need to probably talk about the description of the blog. Third thing that I really need to talk about is the conclusion of the blog, right? So let's say these are my 3 tasks that I want to do: task 1, task 2, task 3, right? And now, since we are developing or we will be developing a lot of Langchain and Langgraph applications, here, in order to probably implement this, we will be defining a workflow. Okay, we will be defining the workflow. Okay, workflow basically means as soon as YT videos are uploaded, what is the next step that needs to happen? And here internally, we will be using LLM models. Okay, we will be using these LLM models. Now, in order to solve this particular use case, how things will happen? Let's say this workflow initially will be like this. My YT video has been uploaded. So what will the user do? User will just give the URL over here. Okay, user will give the URL over here. Then in the next step, what will happen is that we will go to the next step over here. Okay, so here I will be having the URL. So as soon as I get the URL, here we are basically going to do one thing, right? What is the thing that we really want to do over here? We have to probably convert this YT video to some kind of transcript, right? Some kind of transcript, and this is possible in LangChain by using various libraries. Okay, so this is possible, right? We will convert this YT to a transcript. Okay, now you can see the first thing that I'm doing.
Okay, I wanted to know, can we convert, how to convert a video into text using LangChain? Document loaders, YouTube loader. Okay, let's do it later. First, let's
Is that is YT video, we're trying to get the transcript of the video. So we need to save it somewhere, right? That basically means this node is going to give me the output of transcript. So what I will do is that I will create a data model, and this data model will be using or inheriting identity. And with the help of this particular identity, here let's say that we define a class. The class will be nothing but I will say, hey, we have a class called as state. State will be inheriting identity. Okay, will be inheriting identity, and the first variable that we want is transcript. And you know
what happened? Internet fuck. I don't know what's problem with Udemy, but whenever I'm watching Udemy videos, it always happens like it will pause in between. Wait, let's see. I think if I'll watch YouTube videos, it will be smooth. But here only this problem occurring. See, here also at least. Oh, the problem is in internet as well. But I will be able to smoothly watch YouTube videos. It is happening with. Oh fuck. This is very bad. Now I have to wait for it.
string value, right? We will have to get the description of the entire content that I have actually coded in the YT, right? So once we do that, here, by doing this kind of, specifying this kind of data type over here and inheriting identity, we are saying that the output of this particular module, whatever it is basically displaying, should only give transcript as integer. If it gives some other value, then it is going to give us an error, right? So this is the kind of data validation we are talking about. Then in the next step, what we do, in the next step, we go to the next step over here, we take this transcript and convert into log, right? We convert this into log. Now while converting into log, I will be having three different types. One is title, one is description, and the other one is conclusion. Now you know that these three are also type of string only, because this will be also string, this will also be string. So what we can do inside this class, which is inheriting identity, we will also go ahead and define title, which will be of string, description, which will be of string, and conclusion, which will be of string. Right? So once we are defining this, that basically means we are predefining the data types that we will be requiring, and internally you can see that inside this node also LLM will be working, right? Because LLM will be responsible in converting the transcript to log. Right? So this way we are able to get the specific information, right? And here, by defining this entire data types, by using this identity model, we are also saying LLM, hey LLM, you need to provide us some kind of structured output, with this data types variable, right? Like data type should be string over here, title should be string, description should be string, conclusion should be string, right? So here, what we are specifically doing, we need to understand this. Here, internally, by using the identity model, we are trying to make sure that the internal data validation for all these variables happens in a much more easier way as soon as we get the output from the LLMs. So now let me go ahead and quickly open my VS Code.
I just wanted to ask, where is AI? AI, bro. AI roadmap. I will ask here. This LLM supports what supports? It supports structured output, or it is taken KY. I think it supports. I read somewhere. Or taken by LangChain or Langgraph. Retry and pass response. Digit supported. Python class directly. Identity model JSON schema LLM API. So we have think of identity as a Python side effect.
Now in this specific VS Code, what we are basically going to do, I have already created an environment. I'll create my first module that is called as Pydantic. All the materials will be given in the description, in the link that is given in the description of this particular video. So in Krishna Academy, we have prepared this entirely as a free course. You can go ahead and download it from there. So now, just to start with, I will just go ahead and write intro.ipynv. Okay, well, I'll start with ipynv, but before I go ahead, I'll just go ahead and install my ipykernel. Okay, because we will be requiring this. So once I go ahead and install the ipykernel, here you'll be able to see that my installation will probably happen, and then we should be able to select a kernel for this particular Jupyter module. Step by step, we will start with how this identity module can be used for data validation. We create a simple model. When I say models, I'm basically talking about class, how we can inherit from a base model, how that entire data validation happen, and everything. Okay? So let this happen quickly. So once this is done, we will go ahead and select the kernel. I will go ahead and select the Python environment. Let me go ahead and create a markdown. And for this particular markdown, I'll just go ahead and write some information over here. So here, this is the first thing that we're going to discuss. That is identity basics, creating and using models. Okay, and I'll just delete this. So let's see why this ipykernel is taking so much time. Yeah, this is done. In the future classes, I'll also show you one more way, like how you can use UV for handling the entire packages. Okay. So Python basics, creating and using models. Python models are the foundation of data validation in Python. They use the detailed use import
Base model.
.txt. Okay. Now here, I will just go ahead and write Pydantic. Okay. And we will just go ahead and open my terminal and again go ahead and write pip install. It is better that I hide my face so that you should be able to see my screen. Okay, then install -r requirement.txt. Okay, so once we do this, the entire Pydantic module will get installed. Okay, okay. Now what I will do, I will just go here. Now here you can see, I will just go ahead and write from Pydantic import base model. Okay, base model. So as soon as we import this base model, now we'll be able to see that if I just hover through this, what is this base model? Okay, the name of the class defined on the model, there's some information, but it's okay. I'm just go ahead and show you. But this you can just say that it's a base class of creating Pydantic models, which performs the data validation. So guys, now we have imported from Pydantic import base model. Okay, what we're going to do is that first of all, we're just going to start with a simple model, which is inheriting this base model with some of the required fields, and we'll see that how the data validation happens. Okay, now here I'm just going to go ahead and start. Like name is going to and okay, specifically saying that hey, this model is what is the name of the person, and here let's say that I go ahead and define name is equal to fish, age, and then I have something like that. Okay, now if I just go ahead and print person, okay, and execute this, here you can see all the specific information I'm able to see inside this person. Okay, and if you go ahead and see the type of person, okay, here you can see that is a main of person object, right? Now this is fine, right? You'll be able to see that if you also create a data class, I think it will work in a similar way. What additional thing you're basically doing, right? Let's say over here, if you just say, hey, from data class, import data class, right? You can also use this, right? So you use a decorator data class and you can use the same thing, and you don't have to inherit the base model, right? And here you should be able to print this too, right? Right? So here you're getting, okay, this is the person object, and here you're getting name, relation. So what is so different? Why we are inheriting base model? Now here is the magic that you'll be seeing. If I just go ahead and create another object, person one, and let's say over here, name is equal to 35, instead of giving a string value, city is str, instead of giving a string value, if I give some value like 12, integer, now what will happen? Here you'll be able to see that, sorry, this should be person one. Here you'll be able to see that, person, okay, sorry, you have to execute this. Okay, so let's execute this base model. Now, if I go ahead and execute it, here you'll be able to see that I'm getting this specific error, one validation error for person, right? So once we inherit base model, this class validation will take place because of the Pydantic, right? So let's make this as person one and let's make this person. Now, if I go ahead and execute the same thing for the previous one with respect to data class, and if I just go ahead and use this, okay, and if I make this Bangalore 235, will I get an error? The answer is no. I'm not getting an error. That basically means the classes that we're creating or the model that we're creating, where we're using this data class, here the data validation is not at all happening, right? But what it happens that when I do data validation over here, what is basically going to happen? The data validation says that, hey, Krish, we are not going to make sure that we don't give anything other than specified in this specific class, right? So here city is str, but you're giving as an integer. So that is the reason you're getting this data validation. You understand? If I just go ahead and fix these parameters and I tell my LLM, hey, your structured output should come within this particular variable. This can also be a dictionary. And you should display the output in this way, where my name should be string, my age should be integer, city should be str. Just imagine how easy it becomes for you to get the output. Right? So this is basically called as data validation, and this is how we basically do a data validation with the help of Pydantic. Okay, let's see one more example. And this time we will be using some more additional fields. Okay, so the best part of inheriting Pydantic is that the data validation will automatically happen. Right, and this data validation is very, very amazing. Why? Because the backend is Rust. You can see that how fast the data validation will happen. Right? So here you're getting this validation error. You can also handle this particular error, which I'll show you. Okay. Now let me just go. I have defined some fields like name, age, and optional fields. How do we import it? So I'll go ahead and write from typing.
Model with optional.
Okay. Now inside my class, it is inheriting the base model. The first parameter is ID with integer. What does this optional float mean? Optional with default value. So here we are saying that hey, this is an optional float value with none as the default value. Okay, default value. Okay. Now what will this optional do? Okay, indicates the field can be none. Okay, so this field can be null. Okay, none. So here it is a float value. Here it is a boolean. Okay, and by default the value will be true. Okay. Now what I will do? I'll just go ahead and print this. Now see this magic. Okay, I'll just go ahead and print. Hey, employees, ID is equal to 1, John is equal to, name is equal to John, department is equal to 1. I have not given this two values over here, right? So if I just go ahead and print this employee 1, salary will be none is active equal to. See, by default, if I want to specify a specific field, I can keep it as optional with a default value over here as well. Okay, so I hope you are able to understand this too. Very simple. Okay, let's say that I go ahead and write one more thing over here. Let's say employee 2, ID, name, Jane, department, salary 6,000 is active equal to false. You should be able to see this particular value. By default, this will become a floating. Okay, what happens if I remove this and I make it as an integer? Automatic typecasting will also happen. Is there a possibility of typecasting into float? The answer is yes. Yes, it is possible. So here we are able to write it down. Okay, so just to define this, I will also put a markdown so that you should be able to have some kind of references so that you can refer it over here. Okay. Optional type indicate for optional field when the values are provided. Okay. So similarly, let's say that one of the field can also be a list. So for that list, how do we do it? Okay, so we can also create model with list values or list fields. So here what room number will be. So here it's a very simple way. I'll just go ahead and execute this. I'll go ahead and write create to 30 classroom. Let it up all. Right. So I hope you're able to understand this. Okay. Let's try colon. Okay. Let's say invalid val is equal to. I'll just go ahead and write classroom. Okay. And then this will basically be my room number. Room number is A1. Let's say, and then comma 1 to 30. You see over here, if you don't provide the right values with respect to the data, then I'm going to get a validation error. Okay? Otherwise, you can also get a value. So I will just go ahead and write set value error as E because we have not provided the right value, and then I'm just going to get 20. Okay? So here you can see one validation error for classroom. So input should be a valid string type. String type input value is equal to 1 to 3. Input type is int. It's saying that hey, you're providing an int. And how this is basically happening because of the Pydantic. Yeah, Pydantic. So here you can just see this particular example. Right? Let me show you one more very good way of. So here we can also implement Pydantic models. So model with nested values. Okay? Let's say if I have some kind of models with a much more complex structure, okay, then we can also do that. And let me show you one specific example for this also, where you should be able to get an example very easily. Okay? So here you should be able to see this. First of all, I created an address. This is an inheriting base model. The customer I created another class. Here this address is referring to this particular class. That basically means this address will have these three values to each city and zip code. And so that's the reason we say this is a nested model. We are creating models in nested model. And this customer, so you can see over here, customer 1 I'm writing name and address I'm specifying in the form of key value pairs where street is equal to 1 to 3. All these values are there. Okay? And and then I can just go ahead and display this. So here you can see good output. One very amazing thing is that what happens if I just go ahead and keep this zip as in, okay? And here you can see zip code I'm giving a string. Will this get typecasted? Will this be handled by Pydantic? The answer is yes. So you should be able to see that it's automatically converting the string into an integer value. Okay. So I hope you're able to understand all the specific stuff, and I hope you're able to understand why do we use Pydantic, what are the different types of data validation. It's really, really important to probably go ahead and do this kind of data validation stuff. Okay. Now, the next stuff that we are basically going to discuss about is Pydantic field customization and constraints. Okay, so this is what we are basically going to discuss about. This is also really, really important. There is a topic with respect to Pydantic fields, which is specifically used, for some kind of constraints. The field function in the Pydantic analysis model field beyond basic type length. So there's a thing, something called as type length, by allowing you to specify validation rules. So you can also specify some kind of validation rules. Now, by default, whatever data types you're specifying based on that validation is basically getting applied. But on top of that, if you want to add more validation, how do you do it? Okay, so again, I'll just go ahead and import from Pydantic, import base model, and then we'll just go ahead and import field. Okay. Now here, let me go ahead and create some item. Okay, so class item I have over here. That's some kind of constraints on top of that validation that basically happens, right? By default.
Actually,
so here you can see properties, user description, all this specific information. Now it also says that hey, it is basically the schema method is dedicated to model.json schema. Okay. Hello, so welcome to the LangChain series, and in this video we are going to get started with LangChain and OpenAI. Here, this video is super important because some of the important modules that are available in LangChain will be setting it up like Langsmith and Langser. Along with that, you'll be seeing a series of videos. We will be building a sample application, simple sample application with the help of LangChain. There we are going to use OpenAI models. Along with that, if you do not have OpenAI API, then you can also go ahead and use open source models that I'll show you with the help of Llama. Again, the main aim over here is to make sure that what all tools we are going to use in this entire course. I'm going to probably do that entire setup right now so that you'll be able to follow all the lectures as we go ahead. So let me just go ahead and share my screen. So here, this video, what all things we're going to do. First of all, we're going to get started with LangChain, and let me just go ahead and write and OpenAI. Okay. In this quick start, we'll show how to get we'll see how to get set up with LangChain, Langsmith, and Langser. So we'll be discussing about all these three models, important models that are present in LangChain. Then use the most basic and common component of LangChain, like one templates model and output parser. Then we are going to build a simple application, with LangChain, and then we are going to trace our entire application with the help of Langsmith, right? If you really want to do debugging, monitoring, everything, we will be specifically using Langsmith. And then finally, if I want to probably make this entire application in the form of APIs so that it is production ready, I will be using Langsmith. So all these things, not only in this single video, but in the series of video I'll be doing. Once we do it with OpenAI, I know like everybody knows that OpenAI provides the API key. Obviously, you need to put at least $5 credits to check out all these things. The reason why I'm considering OpenAI because it is important. Most of the companies people are using it in the form of APIs as well. So first of all, initially I'll go ahead with OpenAI here, and then we will also go ahead with open source models through Llama. Okay. So initially, the first step is getting set up with LangChain, Langsmith, and Langser. So quickly, let me do one thing. Let me go back to my browser. So here is my entire LangChain page. So over here, you'll be able to see in LangChain, we have a library or module which is called as Langsmith. Along with this, we also have something called as Langser. Okay. So LangChain is a open source framework where you'll be finding a lot of modules, a lot of libraries, which will actually help you develop the GenAI application. So first of all, I'll just go ahead and click on sign up. Okay. And once I sign up, you'll be able to see that you'll be able to log into the Langsmith basically. Like, this Langsmith, why it is used. So we can just go ahead and understand. It will be like if you want to make your LLM app from prototype to production, we will specifically use this entire Langsmith module. So by default, whenever I do the sign up, you have to go ahead and insert your user ID or whatever, like name, all the details, and probably go ahead and sign up with your email ID. In the Langsmith also, if I go ahead and sign up, it will probably give me the same page that I actually have. Okay. Here you can actually see I've created so many different projects. So over here we'll be able to do that time monitoring, everything as such. Along with this, if you go over here and say that I can also upload my own data sets, there's something called annotation queue prompts. If you want to probably do the deployment, I can go ahead and click this. And Langgraph API deployment is also there. And right now, hosted Lang service coming soon. If you're interested, you can sign up for early access. Let's see till the recording of this particular entire course gets over. If I get this particular access, I will send you the tutorial. Okay. So this is the first step. Please go ahead and create an account in LangChain, and automatically you'll be able to create an account with respect to LangChain. Okay. So this is the first step. Everybody needs to have this. Okay. And I will show you that how I will be using this. I will make my entire application everything as such. Now the second thing that we really require is an OpenAI API key. So just go into Google, search for OpenAI API key, and replace use ChatGPT. Okay, keys. For this, it will not be compatible with Zoom, right? And right now, you can obviously that I've used for GPT-4o, GPT-4. So I'll be using these models when I'll be developing an application. Okay. If you want to probably go ahead and upload put some amount again, you have to go to the payments and there you can see cost, activity, the things. If I go ahead and click on release limit, you'll be able to see that I'll also be able to set my limit based on the requirement that I have. So if you go to click on billings, so here you can upload your payment methods. Right now my credit balance is 2.85, but if I require more, I'll be inserting more $5 to $10 and probably showing you how you can actually use this OpenAI API. Okay. But at the end of the day, you will need to use this because many of the companies are using it, right? So there are options of putting up payment methods and all, right? So based on that, you can actually do it. But at the end of the day, I will be using one API key, which I will try to create it over here. I'll also show you how to create it and where I'll be creating my entire environment. Okay. Now let me just go back to my project. So I have actually created each and everything over here. The first thing that I'm actually going to do is that over here you'll be able to see that I've created a lot of folders, which you'll be able to understand. In the requirement.txt, I have put up LangChain. So LangChain is one of the libraries that I'm actually going to use. And since we're going to work with Jupyter notebooks, so what I've actually done is that I've used my kernel. Okay. My kernel this enables to attach kernel to the Jupyter notebook. This is the first thing that I really need to install. Along with this, there are some more installation that I will be doing, which I will be showing you, right? The first thing is that you'll be able to see that I'll go ahead and create my .env file. Now this .env file is super important because with the help of this .env file, okay, the next step we go ahead and put my LangChain API key. Now, why do we require LangChain API key? It is very simple. If you probably go to the browser, right? So let me just show you over here. So if I go to my Langsmith, right? Over here, you'll be able to see if I go ahead and click on settings, right? I'll be requiring one API key because at the end of the day, entire monitoring will be specifically happening over here, right? So if I go ahead and see in this LangChain series, you'll be able to see right now there's no request. But if I go ahead and see in some tutorial one, right? Okay, let me just go ahead and see in the last 7 days, last 20 days. Okay? So nothing is here. So I think let me just go ahead and test some more. Right now, everything looks blank. Okay, but it's okay. We will see this. All time if I go ahead and see over here, I created some request from OpenAI, and here you'll be able to see I'll be able to monitor each and every request. And I'll be talking more about it, but just I'm giving you an idea why we specifically require a LangChain API key because in this portal, I am going to record all my monitoring things, debugging things with respect to the journey I have that I'm actually going to create. So in order to create the API key, just go to the settings over here, click on API key, and select create this API key. Right now I've already created it. If you go ahead and create it, you can give any kind of description over here. Okay, let's say that I'm giving here, this will be my test key, and I'm actually going to create. First thing I have to do is I'll not get. So since we are in the .env file, so first of all I kept my API and this API key as a key, then my LangChain API key. Then I will also go ahead and create my LangChain project. Okay, so I'll just go ahead and write LangChain project. Okay, so this will basically be my LangChain project, and let's say this is my Gen AI app with OpenAI. So this will be my project name that I'm actually going to create. Okay, so I will be requiring this information to start with. Okay, now you may be thinking this, why I have not yet put up this OpenAI API. I'll suggest please go ahead and put your own API. Okay, do not be dependent on mine because I'll keep this hidden. Otherwise, a lot of charges will happen on mine. Okay, so this will be the three APIs that I'll be requiring: LangChain LangChain project, and OpenAI and API. Perfect. Once this is done, now I will go to my requirement.txt. Okay, now here I'll not put that entirely. This library is actually required. It is very simple. What's in my Python.env terminal. So just quickly let me just go ahead and install Python.env. So you can see it is success, and you can see that I was creating my API itself. Now what I'm actually doing. Now the first step is done. LangChain, LangServe. LangServe also I'll be talking more about it. What kind of code will be ready for this. You don't require any code sign first. Only LangChain and LangServe you basically require. Okay. Now in the next step, we will use the most basic and common components of LangChain, like prompt templates, models, and output parsing. So I hope you able to understand this video. This was it from my side. I will see you on the next video. Thank you. Hello, so we are going to continue the LangChain series, and in this video, we will go ahead and set up our entire environment for LangChain so that we will be able to start the coding and we'll be seeing multiple applications of build generative AI applications. Now, what I've actually planned is that I will probably create just one folder. Okay, so let's go ahead and see this. This will be one folder. My entire project will be probably created over here. And let's say the end-to-end projects that I specifically create, I will probably create a different project folder for them. Okay, so go to any folder in any of your drive, and from this, let's go ahead and right-click over here and you get an option of open with code. Right, so here once you click this open with code, you'll be able to see that I'll be having the VS Code. This is one way how you can actually do it. The other way is that I'll just go ahead and copy this path, open my command prompt. Okay, if I've installed Alcon and VS Code, so I'll just go to this particular command, this particular path. So I'll just go ahead and write CD. Yes, and I'll go to my E drive. So here you can see that I'm actually I'm in that same path which I am planning to create my code project itself. So here I will just go ahead and write code dot, and automatically my VS Code will open. So these are two different ways how you can probably start your VS Code. Okay, so I've done this, and now my entire coding will specifically be happening over here. Let me do one thing. Let me just make this as a full screen. Now let us go ahead and first of all create one virtual environment. Since in LangChain, all the things that we're going to probably discuss will be related to LangChain, so it is always necessary that you create your own virtual environment. And with respect to that specific virtual environment, we'll try to do all the installations, and we'll try to probably see what packages will be required and what things. Now, since I don't know like how many of you are familiar with working with VS Code or not, but VS Code I feel is an amazing idea wherein you'll be able to create projects, you'll be able to work with Jupyter Notebook and many more things. So here, what I'm actually going to do first of all. Here you can see that first of all you need to go ahead and open your terminal, right? So in this terminal we will go ahead and create our new terminal. So this is one way. But my entire session I will try to use some shortcuts in VS Code. I just will press Control back symbol, Control plus back symbol, and automatically I'll be able to see that okay, this is my terminal over here. Okay, you can also go ahead and probably just open this terminal by using shortcuts, so that will be much more efficient while working on the project itself. Now here you have multiple options like PowerShell, Git Bash, command prompt, JavaScript debug terminal. So whatever thing you really want to go ahead with, you can go ahead. Again in Mac you'll be having another terminal itself, so you can probably check with respect to the kind of system that you have. But here I'm just going to go ahead and open command terminal. Okay, so this will basically be my command terminal. Now I am going to, as I said, I'm going to probably go ahead and create my own virtual environment. So first of all, what I'm actually going to do, I'll just go ahead and create minus p v and v will be my virtual environment. I will just go ahead and use my Python version 3.10. 3.10 I'm using because the most of the stable libraries that are there, I think it is compatible to Python 3.10, and I think it is also 3.11. In 3.12, there's still a lot of developments that are specifically happening, new things happening. So once that actually becomes stable, you can also work with that. So I'm just going to go ahead with Python equal to 3.10, and here along with this, I will also say by default white, so that what are the default installation that is going to probably take place with respect to this particular virtual environment that is going to happen, that I really want to work for, and packages will get installed. Till this is getting installed, I will just go ahead and create my requirements.txt. Requirements. Either I'm also going to install it. I just require LangChain to show you that how you can probably go ahead with the installation and this requirement of PHP. Now, once my virtual environment is created, so here you can see this is my VNV folder. I will go ahead and activate this particular environment. So let's go ahead and activate this. So here I'm going to write contact activate VNV, and here is my virtual environment. Okay. Now already my packages have been I've written that in the LangChain itself. So let me quickly go ahead and clear my screen, and let me just go ahead and write install minus our requirement of PHP. So here you'll be able to see okay install I've written for this. So let me just go ahead and do the requirement of PHP installation. So automatically you'll be able to see LangChain core, all the installation will automatically happen. Okay. So once this installation basically happens, we are going to start our LangChain projects, and when we'll be starting multiple modules in LangChain, where we'll be discussing step by step and how you can specifically use it. Along with LangChain, I would also like to probably install one more package, which I've already discussed in my Python module, which is nothing but IPyKernel. Now, IPyKernel is something which we are going to use it only to make sure that we'll be able to create a selected kernel for our Jupyter Notebook file. Initially, all the topics that we are going to learn will be mostly through Jupyter Notebook, but later on, once we get our fundamental or basics clear, we'll also be developing end-to-end projects. So yes, this was all the steps that we really need to do in order to create a virtual environment. Now I'll just go ahead and probably create my first module, whatever things I really want to develop over here with respect to LangChain. And inside this, let's say I'm going to go ahead and probably work with IPyKernel files. I'll just go ahead and create one file and start my which I'm going to probably show you in the next video. Right? So yes, this was it from my side. In this particular video, I've shown how you can actually go ahead and create a virtual environment and download the requirement of I just use one packages, and as we go ahead, we will be using multiple packages. Anyway, so we are going to continue the discussion with respect to LangChain. In this video, we are going to discuss about some of the very important components of LangChain that we use while generating a Gen AI application. Already in our previous video, we have seen the entire ecosystem of LangChain, and we have also done the setup of LangChain. And before I go ahead and do the coding and start using this library, we will just try to understand what are the most common components that we will be specifically using. And in this video, I'll be taking an example of a RAG application that is nothing but retrieval augmented generation. What does this RAG actually mean? And we are just going to create a lot of projects and we go ahead. But let me just give you a brief idea about RAG, what exactly is a RAG application. Let's say, and by just seeing this particular diagram, you'll be able to understand. Okay. Now, RAG augmented generation basically means, let's say you have a specific data source. Okay. Now, this data source may be some kind of PDF file, right? Let's say you have thousands and thousands of PDF files. Now, if you want to make this PDF file as a document Q&A application, that basically whenever I'll ask a question, automatically my Gen AI application, okay, and let's say I'm probably creating a Gen AI over here, okay, so this is my Gen AI. What I will do is that if a user asks any query, it should be able to probably send this query to this entire data source, and from this PDF we should be able to get the response. Okay, so this in short is the entire process of RAG. But again, I've just given you a 10,000 height overview, right? 10,000 feet height overview. So that is the reason I just told that, hey, we have some kind of data set where we have thousands and thousands of PDF, and now what I'm doing is that I'm creating a generative AI application. This generative AI application, what task it performs is that whenever input is given from a user or regarding any question from this particular PDF, I should be able to get it by having a conversation with this entire data source, right? That's nothing but tons of PDF that you have. Okay, this is just a basic example, but we'll discuss more about it. Now, if I just consider this application, okay, and most of the common components that we use in LangChain to develop this kind of application and similar kind of application itself, so we'll try to understand step by step how we will probably be developing, and then along with that, what all components are used in each and every step, we'll try to understand. Okay, so initially, what we do is that whenever I have this kind of use case, first of all, we need to load the data set, right? Now, loading the data set will be from various data sources. Okay, now this data source can be anything, and that is the reason we have to use this diagram. It can be a PDF, it can be an Excel file, it can be a JSON file, it can be an image, it can be videos, it can be URLs, right? So initially, whenever we develop this kind of application, the first step that we specifically use is data ingestion. So this is the most important component in LangChain. Okay, and in the upcoming video, the next video, I will try to show you with the help of LangChain how you will be able to perform data ingestion with respect to various data sources. Okay, so that is the first component that we are going to discuss. Then what we do is that after basically using this entire data, like let's say we have ingested this data, we have loaded this particular data. Then the next step will be that we will divide this data, we'll split this data into smaller chunks. Okay, so here what we are doing, we will take this entire data and we will split into text chunks. Okay, it can be text chunks, it can be document chunks. The reason is very simple. Why we are basically doing this? Because see, in the later stages, we will be specifically using LLM models, or it can be multimodal, right? And one of the very important property of this particular LLM model is that it has some limitation with respect to context. So for different LLM models that we'll be seeing like OpenAI or Google Gemini Pro or any different kind of models that are even available in coming days, open source models like Langgraph, they have some limitation with respect to the context size. Okay. So based on this particular context size, what we will be doing is that there is a restriction. The size, like if my LLM model, I can only give this much maximum context size of data, so that it will be able to understand from where it needs to take the query or response, and it should give it as an output, right? So that is the reason what we do is that we divide this particular data, right? And this data can be having 1,000 PDFs, all the data from 1,000 PDFs, it can become a huge data set. So we take that data and we'll split that into text chunks. So that is the second step that we'll be seeing. And splitting these chunks is done by various other techniques. So here I will just consider this as a data transformation technique. So this is nothing but this is my data transformation. Here my main aim is to transform the data or divide this data into chunks. So this is the second important component that we will do. And again, based on our upcoming videos, we'll discuss each and every component. Okay? Now coming to the third and the important step, which is called as embedding. Okay, embedding is nothing but it is just embedding. Okay, so here we are basically going to do text embedding. Now what does text embedding basically mean? We will take this entire text and we will convert into vectors. Okay, now why do we require vectors? Because see, whenever we query this kind of data source, unless until we do convert this text into vectors, over there algorithms such as similarity search, or see one of the most important algorithm that gets applied when you're working with this kind of text data is nothing but similarity search. Okay, similarity search. And it will basically be using a cosine search over here to try to understand based on the vectors which are the similar context, which are the similar sentence that I'm actually searching from. Based on that, we will read those particular context. Okay? So that is the reason we basically use embedding techniques. Now in this embedding techniques, you have different kinds of embedding. OpenAI has OpenAI embeddings. You also have open source embeddings for different models. Even in Hugging Face, you'll be seeing a lot of open source models. All of them specifically have its own embedding techniques. Okay? Even Google Gemini Pro has its own embedding techniques. So we will again be seeing that whenever we are developing a particular application. So this was the third step. Now coming to the fourth step. So here you can see I'll take this text and convert this into vectors. The vectors will look something like this. Okay? Now this vectors, once we convert it, we really need to store it somewhere, right? Because we can't just keep it in our local storage. So for this, we will be using a store, and this store is nothing but this is basically called as vector store database. Okay, vector store DB. We will be seeing different vector store DB. First example is nothing but we will go ahead and see Fires. Then there is something called as Chroma DB. In our course, we'll also be seeing Astra DB. Okay, so different vector databases will be see how we can basically save this entire data into this type of vector database that we are going to see. Okay, and that is what this is exactly a vector database. And what you can also do is that from this vector database, you can also directly query anything that you want. But the result or the response that you are basically going to get will be the context information. Okay, it will be the context information, and it usually uses the similarity search. Okay, so this is my fourth step that usually happens. Now, once I save this entirely into the vector DB, vector store DB, okay, now we go to the second most important step. Okay, and this is my second. You can just consider that this is my second module. This is my first module. In the first module, you have this particular 4 steps. Okay, and in the second module, you have some more steps. Okay, now while we are working with vector store DB, okay, in the second module, you will be seeing that a user will be able to ask any questions. Okay, and what we do, we also design our separate prompt. So here is your user question. Along with this, we combine with this particular prompt. This prompt usually says that, hey, you are an LLM model, you need to behave something like this. I'll say, hey, act as an AI researcher and try to answer all the questions that is given by the user. Okay, so if I give this kind of prompt, any LLM model that we are going to use, it will act like an AI researcher. Okay, so here prompt is just like the message that I'm giving to my AI assistant. Okay, AI assistant, like what it needs to be here. Okay, so once I give this particular prompt, then any question that is given over here, we will try to combine with this particular prompt. Okay, so as soon as we give this particular question, okay, this question initially will be searched from this vector store. Okay, from this vector store. Then from that particular vector store, we will get some context information. So for doing that purpose, to basically query from the vector store, we really need to understand 2 important things. One is there's something called as document stop float chain. Okay, this is one thing which we will be learning about. Okay, this is also one very important component. And the second thing is something called as the retrieval chain. Or I'll not just say 2. I can just consider it as one because document stop float chain will be a part of that. Okay, so here we need to understand about something called as the retrieval chain. So this retrieval chain, how it is basically created. And what is this retrieval chain? This retrieval chain is nothing but it is an interface
Bro, fuck. I'm not able to focus.
This retrieval chain is nothing but it is an interface.
Bro, fuck. Hard. I will watch these tutorial again. I don't know. It's like I don't know. I'm feeling sleeping today.
Which is responsible for querying the vector store DB. Stand two important things. You can query anything that you want, but the result of the third and the important step, which is from this PDF, we should be able to get the response. Okay? So this in short, showing with respect to LangChain. In this video, we are going to discuss about some of the very important components of LangChain that we use while generating a Gen AI application. Already in our previous video, we have seen the entire ecosystem of LangChain, and we have also done the setup of LangChain. And before I go ahead and do the coding and start using this library, we will just try to understand what are the most common components that we will be specifically using. And in this video, I'll be taking an example of a RAG application, that is nothing but retrieval augmented generation. What does this RAG actually mean? Is that, and we are just going to create a lot of projects that we do have. But let me just give you a brief idea about RAG, what exactly is a RAG application. Let's say, and by just seeing this particular diagram, you'll be able to understand. Okay. Now, RAG augmented generation basically means, let's say you have a specific data source. Okay. Now, this data source may be some kind of PDF file, right? Let's say you have thousands and thousands of PDF files. Now, if you want to make this PDF file as a document Q&A application, that basically whenever I ask a question, automatically my Gen AI application, okay, let's say I'm probably creating a Gen AI over here, okay, so this is my Gen AI. What I will do is that if a user asks any query, it should be able to probably send this query to this entire data source, and from this PDF we should be able to get the response. Okay, so this in short is the entire process of RAG. But again, I've just given you a 10,000 height overview, right? 10,000 feet height overview. So that is the reason I just told that, hey, we have some kind of data set where we have thousands and thousands of PDF, and now what I'm doing is I'm creating a generative AI application. This generative AI application, what task it performs is that whenever input is given from a user or regarding any questions from this particular PDF, I should be able to get it by having a conversation with this entire data source, right? That's nothing but tons of PDF that we have. Okay, this is just a basic example, but we'll discuss more about it. Now, if I just consider this application, okay, and most of the common components that we use in LangChain to develop this kind of application and similar kind of application itself, so we'll try to understand step by step how we will probably be developing, and then along with that, what all components are used in each and every step, we'll try to understand. Okay, so initially, what we do is that whenever I have this kind of use case, first of all, we need to load the data set. Right? Now, loading the data set will be from various data sources. Okay, now this data source can be anything. So that is the reason we have used this diagram. It can be a PDF. It can be an Excel file, it can be a JSON file, it can be an image, it can be videos, it can be URLs, right? So initially, whenever we develop this kind of application, the first step that we specifically use is data ingestion. So this is the most important component in LangChain, okay? And in the upcoming video, the next video, I will try to show you with the help of LangChain how you will be able to perform data ingestion with respect to various data sources. Okay, so that is the first component that we are going to discuss. Then what we do is that after basically using this entire data, like let's say we have ingested this data, we have loaded this particular data. Then the next step will be that we will divide this data, we'll split this data into smaller chunks. Okay, so here what we are doing, we will take this entire data and we will split into text chunks. Okay, it can be text chunks, it can be document chunks. The reason is very simple. Why we are basically doing this? Because see, in the later stages, we will be specifically using LLM models, or it can be multi-model, right? And one of the very important property of this particular LLM model is that it has some limitation with respect to context. So for different LLM models that we'll be seeing, like OpenAI or Google Gemini Pro or any different kind of models that are even available in common place, open source models like Langgraph, they have some limitation with respect to the context size. Okay? So based on this particular context size, what we will be doing is that there is a restriction. The size, like if my LLM model, I can only give this much maximum context size of data, so that we'll be able to understand from where it needs to take the query or response, and it needs to give it as an output, right? So that is the reason what we do is that we divide this particular data, right? And this data can be having 1,000 PDFs, to read all the data from 1,000 PDFs, it can become a huge data set. So we'll take that data and we'll split that into text chunks. So that is the second step that we'll be seeing. And splitting these chunks is done by various other techniques. So here I will just consider this as a data transformation technique. So this is nothing but this is my data transformation. Here my main aim is to transform the data or divide the data into chunks. So this is the second important component that we will be doing. And again, based on our upcoming videos, we'll discuss each and every component. Okay? Now coming to the third and the important step, which is called as embedding. Okay, embedding is nothing but it is just embedding. Okay, so here we are basically going to do text embedding. Now, what does text embedding mean? We will take this entire text and we will convert into vectors. Okay, now why do we require vectors? Because see, whenever we query this kind of data source, unless until we don't convert this text into vectors, over there algorithms such as similarity search. Because see, one of the most important algorithm that gets applied when we are working with this kind of text data is nothing but similarity search. Okay, similarity search. And it will basically be using a cosine search over here to try to understand based on the vectors which are the similar context, which are the similar settings that I'm actually searching for. Based on that, we will retrieve those particular context. Okay? So that is the reason we basically use embedding techniques. Now, in this embedding techniques, you have different kinds of embedding. OpenAI has OpenAI embeddings. You also have open source embeddings, but different models. Even in Hugging Face, you'll be seeing a lot of open source models. All of them specifically has its own embedding techniques. Okay? Even Google Gemini Pro has its own embedding techniques. So we will again be seeing that whenever we are developing that particular application. So this was the third step. Now coming to the fourth step. So here you can see I'll take this text and convert this into vectors. So it will look something like this. Okay? Now this vectors, once we convert it, we really need to store it somewhere, right? Because we can't just keep it in our local file. So for this, we will be using a store, and this store is nothing but this is basically called as vector store database. Okay, vector store DB. We will be seeing different vector store DB. First example is nothing but we will go ahead and see fires. Then there is something called as Chroma DB. In our course, we'll also be seeing Astra DB. Okay. So different vector databases will be see how we can basically save this entire data into this kind of vector database that we are able to see. Okay, and that is what this is exactly a vector database. And what you can also do is that from this vector database, you can also directly query anything that you want. But the result or the response that you are basically going to get will be the context information. Okay, it will be the context information, and it usually uses the similarity search. Okay, so this is my fourth step that usually happens. Now, once I save this entirely into the vector DB, vector store DB, okay, now we go to the second most important step. Okay, and this is my second. You can just consider that this is my second module. This is my first module. In the first module, you have this particular four steps. Okay, and in the second module, you have some more steps. Okay, now while we are working with vector store DB, okay, in the second module, you will be seeing that a user will be able to ask any questions. Okay, and what we do, we also design our separate prompt. So here is your user question. Along with this, we combine with this particular prompt. This prompt usually says that, hey, you are an LLM model, you need to behave something like this. I'll say, hey, act as an AI researcher and try to answer all the questions that is given by the user. Okay, so if I give this kind of prompt, any LLM model that we are able to use, it will start to get the four steps. Okay, and in the second module, you have some more steps. Okay, now while we are working with vector store DB, okay, in the second module, you will be seeing that a user will be able to ask any questions. Okay, and what we do, we also design our separate prompt. So here is your user question. Along with this, we combine with this particular prompt. This prompt usually says that, hey, you are an LLM model, you need to behave something like this. I'll say, hey, act as an AI researcher and try to answer all the questions that is given by the user. Okay, so if I give this kind of prompt, any LLM model that we are able to use, it will act like an AI researcher. Okay, so here prompt is just like the message that I am giving to my AI assistant. Okay, AI assistant, like what it needs to behave like. Okay, so once I give this particular prompt, then any question that is given over here, we will try to combine with this particular prompt. Okay, so as soon as we give this particular question, okay, this question initially will be searched from this vector store. Okay, from this vector store. Then from that particular vector store, we will get some context information. So for doing that purpose, to basically query from the vector store, we really need to understand two important things. One is there is something called as document stop float chain. Okay, this is one thing which we will be learning about. Okay, this is also one very important component. And the second thing is something called as the retrieval chain. But I'll not just say two. I can just consider it as one because document stop float chain will be a part of that. Okay, so here we need to understand about something called as the retrieval chain. So this retrieval chain, how it is basically created. And what is this retrieval chain? This retrieval chain is nothing but it is an interface which is responsible in querying the vector store DB. Vector store DB. Okay, and based on this particular query, I will be able to get the response. Once I get the response to this retrieval chain, I will basically be having my context info. Context info basically means based on the query, where is the similar data in that particular PDF, that entire context will be picked up, right? And along with this context info, we will be combining this prompt template and finally giving to the LLM model to get my output response. So this, in short, is the entire cycle over here. Okay. Now, what will happen in the next video? First of all, we'll see what are the different data ingestion techniques in LangGraph. You'll be amazed to see like what all different data ingestion techniques are there. Right. The second thing that I'm actually going to show you, if I take up any data, how will I be able to divide that into chunks? This is also amazing. Like multiple properties are specifically there. Then the third thing that I'm actually going to show you, which all embedding techniques we can specifically use. Right. There are embedding techniques like FIRE, ChromaDB, AstraDB. We will be seeing multiple embedding techniques. Okay. Sorry, not FIRE, ChromaDB, AstraDB. This is vector store DB. But we will try to see with respect to OpenAI, I have a different embedding technique. With respect to open source models, I have a different embedding technique. So we will try to see that embedding techniques, which responsibility will be for converting the text data into vectors. And finally, we'll also be seeing that we'll also discuss about vector store DB, right? And then we'll combine all these things and we will be creating some amazing projects. We'll also be learning about retrieval chain. So step by step, we will break down each of these things because these are most of the common components that are used in every project of Gemini, right? So I hope you like this particular video. These are some of the very important components of LangGraph which you should never miss it out, and definitely you should know all these things. So yes, this was it from my side. I will see you all in the next video. Thank you. Hello, so we are going to continue the discussion with respect to LangChain. In our previous video, I had actually shown you the example like what we will be specifically doing step by step, from data ingestion to data transformation.
I sleepy next level है. Let me start in the morning. I don't know what's happening. Okay, I will start in the morning. I will try to wake up on time. And thank you so much. Bye bye. See you tomorrow. Good night.